Now that we have discussed about a cylinder and its volume, now comes the next question. What could be the volume of a cone? In similar manner, in this session, let's see how we can derive the formula for volume of a cone. We all know that a cone has its own shape. So taking the shape of a cone, which looks somewhat like this, and then fixing from here, from the center, this distance is called radius and this distance is called height. So in a cone, we define this to be radius and this to be height. And using the dimensions of radius and height, of course, we have a slant height denoted by L. So by using the dimensions of R, H and L, we can define the volume of a cone, which is given by the formula volume of a cone is 1/3 pi r square h unit cube. Is how I get the formula. Volume of a cone is given by 1/3 pi r square h. Note, it's a very important note I make here, that volume of cone is 1/3 of the volume of cylinder from which it is derived. This is very important to understand because we understand a cone being generated from a cylinder. So volume of a cone is always 1/3 of the volume of the cylinder, which you already discussed in the previous session as pi r square h. So 1/3 of volume of cylinder from which it is derived. What do we mean by from which it is derived? For example, I take a cylinder. Imagine I cut the cylinder exactly from center. So that I get something like this. So we assume that if a cylinder is cut into 3 parts, part 1, part 2 and part 3, this clearly is said to be a cone which is generated from this cylinder, and hence a cone generated from a cylinder is 1/3 part of the entire cylinder, and hence volume of a cone is 1/3 of the volume of cylinder from which it is derived. Cut the cone, you get 3 equal parts, and hence this volume of a cone would be exactly 1/3 of the entire cylinder, covering part 1, part 2 and part 3. Is how we understand a very important geometrical concept connecting cylinder and a cone, given by this relation. Volume of a cone is 1/3 pi r square h, where r is the radius and h is the height of the cone. Now that we have discussed about a cylinder and a cone, now the last geometrical structure, solid figure, which we're going to discuss now is about a sphere. What would be the volume of a sphere is what is today's session. So let's see what could be the volume of a sphere. Imagine I take a sphere which is this, and say the radius of the sphere is, say, r, capital R. If the radius of the sphere is r, then the whole of the volume is based on the radius. So here we have a formula which says volume of a sphere is given by 4 by 3 pi r cube unit cube. Volume of a sphere is 4 by 3 pi r cube, is how we understand, with r being the radius. So with this, it's clearly understood that if the volume of a sphere is 4 by 3 pi r cube, then volume of a hemisphere is half of the volume of the sphere, that is 2 by 3 pi r cube unit cube, because exactly a hemisphere is nothing but half of the sphere. So we have this to be, this is the radius and this is the hemisphere, which has 2 by 3 pi r cube unit cube. Volume of a sphere is 4 by 3 pi r cube. Volume of a hemisphere, which is exactly half of the sphere, is 2 by 3 pi r cube unit cube, where r is the radius of the sphere. Let's see some example problem to understand the concept more stronger. For example, I have a sphere whose radius is say 3 centimeters. Let's see what could be, whose radius is say 3 meters. Then volume of the given sphere whose radius is given to be 3 meters is clearly given by the formula 4 by 3 pi r cube. So 4 by 3 pi r cube, which is substituted with the value of the radius r. This gives me 3 squared 9 9 fours 36 pi meter cube, is how we understand the volume of the sphere with radius 3 meters is 36 pi meter cube. Answer in terms of pi, using the formula 4 by 3 pi r cube. Volume of sphere and volume of hemisphere.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.